Okay, students, let's talk about limiting reagent, also called limiting reactant. All right, so when you have a chemical reaction occurring and you have two substances that are reacting to form product, one may be in excess while the other is what we call the limiting reagent. It is the one that is consumed to form product, and we call that again the limiting reagent or limiting reactant. So typically a limiting reactant or limiting reagent problem will read as follows. Benzene reacts with bromine to produce bromobenzene according to the following equation. If 60.0 grams of benzene is mixed with 135 grams of bromine, which is the limiting reagent? That's part A of the problem. And part B of the problem is how many grams of bromobenzene are formed in the reaction. So they give us grams of benzene here, 60.0 grams of benzene, and they give us grams of bromine, which is 135 grams of bromine. Now, as always, first thing we want to do is make sure our chemical equation is balanced. So we have 6 carbons, we have 6 hydrogens, and we have 2 bromines here. Over here we have 6 carbons, we have 6 hydrogens. Oh boy, let's see here. Let me erase that. Just erase all of this. All right, 6 hydrogens, and we have 2 bromines. So looks like we're balanced, guys. We didn't even have to do anything here. All right, in terms of adjusting stoichiometric coefficients. Okay, so how am I going to find out which is my limiting and which is in excess? All right, here's what we can do, guys. We can go ahead and calculate how many grams of bromobenzene will produce from, say, 60 grams of benzene, and then we could do the same calculation with the 135 grams of bromine. Whichever one gives us the lowest number of grams of bromobenzene, that is going to be our limiting reagent. And guess what? That is also going to be what we call our theoretical yield. So what we're calculating here for bromobenzene is the theoretical yield. That is the maximum amount of product I can make based on my limiting reactant. I can only make as much product as I am limited by. Okay, so this is what we're calculating, is the theoretical yield when we calculate the grams of bromobenzene. So let's get started. So we'll say number of grams of C6H5Br, that is bromobenzene. So we'll start with benzene. So we'll say 60.0 grams of C6H6. Now I'm in grams of bromobenzene. I want to get in moles. Grams of benzene. I want to get in moles of benzene. And so what I need to use is the molar mass for benzene. Well, I got 6 carbons here, so 6 times 12 is 72, and since I'm calculating molar mass, it's going to be 72 grams. I got 6 hydrogens. 6 times 1 is 6, so that's molar mass, so that's 6 grams. And so this will be 78 grams, and that will equal to 1 mole. That's the molar mass of benzene. So I'm going to put the 78 grams on the bottom, like so. And I'm going to put the 1 mole of benzene up top because I want the grams of benzene to cancel. Now that I'm in moles of benzene, I am going to use the mole ratio, which in this case is 1:1 between benzene and bromobenzene. So for 1 mole of bromobenzene, there is 1 mole of benzene, which I'll write at the bottom here, because ultimately I want moles of benzene to cancel. So the units are diagonal to each other, so they cancel. Now I need to calculate the molar mass of bromobenzene. Well, it turns out I did that calculation already. So this here is 77 plus 79.9. That will give me 156. Sorry here. 156. Yeah, 156.9. Just doing some math in my head here, guys. 156.9 grams, and that will equal to 1 mole. So that's the molar mass of bromobenzene. The molar mass of bromobenzene is 156.9. Let's see, 79 grams. That's the mass of bromine. And then I have 77 grams. So yeah, this is 9. This will be 6. Carry the 1. That'll be 156 grams. Okay, so that's equal to 1 mole. So 156.9 grams of bromobenzene. And I'll divide that by 1 mole of bromobenzene. So that moles of bromobenzene cancels, and this is going to equal to 120.8 grams of bromobenzene. All right, I'll write that here. All right, so now let's do the same calculation. We'll calculate how many grams of bromobenzene I will produce from 135 grams of bromine. All right, so this sets up much the same way. I'm going to get in moles of bromine by dividing the 135 grams of bromine by its molar mass. So that corresponds to 159.8 grams of bromine. Remember, each bromine has a mass of 79.9. Okay, so I have 2, so 2 times that gives me 159.8 grams for 1 mole of bromine. And now I'm going to use the mole ratio between bromine and bromobenzene. So that's 1:1. So 1 mole of bromobenzene will go up top because I want to get in moles of bromobenzene. And 1 mole of bromine will be on the bottom, so that moles of bromine cancels. Now I'm in moles of bromobenzene. So now we already have the molar mass for that. It's 156.9 grams of bromobenzene divided by 1 mole of bromobenzene. so that moles of bromobenzene cancels here. And so this will equal to, I get 132.5 grams of bromobenzene. All right, so from these calculations, we can determine that benzene is our limiting reactant. So because this gives us the lowest, this is the lowest theoretical yield. Okay. All right. This is the lowest theoretical yield. So what that means is that benzene, I'll write it down here. Benzene, I'll just write the formula. We'll do it like that. So C6H6 is the limiting reagent, and the theoretical yield, or the number of grams of bromobenzene formed from the reaction, which we call the theoretical yield, okay, is equal to 120.8 grams of bromobenzene. That's the maximum amount of product that I can make from this reaction, is 120.8, which I guess looking at sig figs, we got 3 sig figs here, 3 sig figs, 3 sig figs here, 3 sig figs here. I guess I should report this to 3 sig figs, so it's going to be 121 grams of bromobenzene. That's the maximum amount of product I can make based on the limiting reactant. We said the limiting reactant or limiting reagent is benzene. So that's our limiting reactant. And the number of grams of bromobenzene that is formed from this reaction is 121 grams. Okay, so this is how you can calculate simultaneously, find your limiting reactant or limiting reagent, as well as calculate what we call your theoretical yield, which is the maximum amount of product you can make. All right, so if you would like, you can go back and review the video to see the steps that we took to carry out the calculations. Okay. So in the next video, what I'll be discussing is how we find the theoretical yield, and based on the actual yield, we calculate what is called the percent yield. So see you in the next video.